For example 5, we have two-digit numbers are formed from the digits 0, 1, 2, 4, 5, 6, 7, 8, and 9. Letter A, how many two-digit numbers are formed? Again, we're asked to form two-digit numbers from 0 to 9. Take note that a two-digit number cannot start with 0. Excluding 0, we only have 9 options from 1 to 9 for our first position. And that's 9 times, for the second position of our two-digit numbers can end with 0, 1, 2, 4 to 9. So meaning, for our second position, we have 10 options. Multiplying these outcomes, we have 9 times 10, that is 9 times 10 equals 90. So we have a total of 90 two-digit numbers. 90 possible outcomes. Possible outcomes for a two-digit number from the digits 0 to 9. For letter B, how many of these are even? Again, we are asked to form two-digit numbers. Take note that by the definition of an even number ends with a number that is divisible by 2. So our options are 0, we have 0, 2, 4, 6, and 8 for the second position. That is a total of 5 possible outcomes. And for our first digit, or for the first position, we have 9 options out of the 10 because again, a two-digit number cannot start with 0. So we only have 9 options for that. Multiplying them, we have 9 times 5 equals 45. Meaning we have 45 possible, we have 45 possible even numbers out of the 90 possible outcomes, and with that, we need to remember that a number will either be even or odd. And since we have 90 possible outcomes, half of it, which is 45, are even. The remaining numbers, or the remaining 45 outcomes, would be odd. Okay. For letter D, how many of these are less than 50? We are interested in forming two-digit numbers. If it's less than 50, meaning our numbers or our two-digit number can either start with 1, with 2, with 3, or 4. So we are left with 4 options or 4 digits to choose from for our first number. And we have 4 possible outcomes for the first step. Multiply 10 digits because if our number is less than 50, any two digits starting from 1, 2, 3, and 4 and ends with 0 to 9 would be less than 50. So meaning we have 10 possible options for the second position, giving us a total of 40 possible outcomes or 40 possible two-digit numbers that are less than 50. Next, we have how many of these are greater than 49 but less than 70 two-digit numbers. And since it's greater than 49 but less than 70, meaning we only have 2 possible options for our first position. We can either start with 5 or with 6, giving us 2 possible outcomes for the first step. Multiply the number of possible outcomes for the second step, where our number should be greater than 49 but less than 70, and we can our two-digit number can end with any of the digits available, and we have 10 options for our second position, leaving us with 20 possible outcomes or 20 possible two-digit numbers that are greater than 49 but less than 70. Okay. Suppose we have 5 cards numbered 1, 2, 3, 4, and 5. The question is, how many 5-digit numbers can be formed considering that a card may only be used once, meaning a number may not be repeated. Applying FTC, we have 5-digit numbers, so meaning we have to fill in 5 positions where a number cannot be repeated. And with these options that we have, for the first position, for our first digit, we can have 5 options. So meaning that would be 5 possible outcomes or 5 possible options for the first position. And since a card can only be used once, there will be 4 options left for the second position. And since we already have chosen 2 positions for the first, 2 numbers or digits, for the first 2 positions, we are left with 3 possible options for the third position and 2 possible options for the fourth position, and for the fifth position, we are left with 1 possible option. Applying FTC with that, multiplying 5 times 4 times 3 times 2 and 1 will give us 120. One possible outcome of this event is 12,345. Another possible outcome is 12,354. Observe that switching the positions of the fourth and the fifth digits will result to a new number. Such an arrangement of objects where the order of objects being arranged matters is called permutation.